Hello students, today is my first online class with you. So I welcome you all to the department. So my portion is unit 4, unit 5 of the syllabus, that is differential equation. Okay, formation of differential equation, those separation method, brief review of those uh, separation of method of variables, Claret's equation, and so on. So here I'll just define again what is differential equation before I start with the formation of differential equation. You have done this in class 11, 12, how to form a differential equation and what are the derivatives of how to find the derivatives of an equation. So here, with the help of that, I hope you will be able to understand how to form a differential equation with the help of our working rules. So differential equation here, what is defined? It is defined as an equation involving differential coefficients with or without their variable from which these differential coefficients are derived. So what is a differential equation? It is an equation which involves a differential coefficients with or without their variables from which the differential coefficients are derived. For example, dy dx is equal to e to the power x is one such example of a differential equation. This is called a differential equation of first order. Now you have d2y dx2 plus dy dx plus y equal to x is a differential equation of second order. Or you can just have this one, d2y dx2 minus y is equal to e to the power x is also a differential equation of second order, where the coefficients of this first order, that is dy dx, is 0. So here, as you can see here, the coefficient of this is equal to 1 and the coefficient of this is equal to minus 1. So what are the working rules to form a differential equation? So you are given a family of curve, okay? You are given a family of curves, say fxyz, let fxy c1 is equal to 0. This is a family of curve, and here, as you can see here, this given family of curves involves only one differential or only one constant term. So how to form a differential equation from this given family of curves is that you have to differentiate this given equation once only to eliminate the constant term c. So once you eliminate the constant term c1 here, then the equation you obtain there is by eliminating the constant term c1 is called a differential equation. Now, if it involves two constants, say fxy c1 comma c2, then you have to differentiate this family of curve 2 times in order to eliminate the constant term c1 c2. For example, if you have here, okay, I'll show you the problems also. How to form a differential equation depends on the constant term. The number of constant terms, you have to differentiate it. So in general, if the given differential equation fxy contains c1, c2 dash dash cn constant terms, so you name this as equation 1. What you do is that since there are n constant terms, what we have here is that to form a differential equation from this family of curve, you have to differentiate this n times. So once you differentiate it n times, you will get n additional equation including this given family equation. So after that, you eliminate using this all those n plus 1 equations. Eliminate the constant term c1, c2, c dash dash cn from those equations that you have different from those n equations, n plus 1 equations. The required equation you will obtain here is a differential equation of order n, that is of the form dny dx, and because in this case you differentiate it n times, since there are n constant term, you have to eliminate. To form a differential equation means you have to eliminate the constant term. And how to differentiate, how many times you have to differentiate the given family of curves, it depends on the number of constant terms. If it involves only one constant term, like in this case, so differentiate this equation 1 only once. and then eliminate this C1 from there to obtain the required differential equation. Now, if it involves two constant terms, C1, C2, the given family of curves involve two family of curves, then you have to differentiate it 2 times to eliminate C1, C2, and so on. So in general, if it involves n constant terms, so you have to differentiate it n times to get n plus 1 equations, and with the help of those n plus 1 equations, eliminate all those constants C1, C2 to obtain the required differential equation. So here are the working rules to form a differential equation. Step 1 is write the given equation of the given family of curve. First, you have to write down the equation of the given family of curve. Now, step 2 is differentiate the equation you get. So differentiate the equation of step 1, that is the given family of curves n times, because if it involves in general, here this is the working rule for equation involving n arbitrary constants. So you differentiate the equation of step 1 n times so as to get n additional equations containing n arbitrary constants and derivatives. So after differentiating it n times, this given equation of family of curve, then you eliminate n arbitrary constants from the n plus 1 equation. Why it is n plus 1? Because the given family of curves, you gave it as equation 1, and then since it involves n arbitrary constants, so you differentiate it n times, so there will be n plus 1 equations obtained in step 1 and 2. Thus, the required, by eliminating all those arbitrary constants from those equations you obtain in step 1 and 2, you will get the required differential equation involving a derivatives of nth order. So for example, here you are given here this given family of curve is this: y is equal to a e to the power 2x plus b e to the power minus 2x. Name it as equation 1. So as you can see here in this given equation, how many constant terms are there? There are 2 constant terms. So to obtain the differential equation, so I have to, by the above working rule, so I have to differentiate this equation 1 2 times to eliminate a and b. So first, differentiating 1 with respect to x, we get, okay, so dy dx is equal to a, and what is the derivatives of e to the power 2x? It is 2e to the power 2x, and then plus b into minus 2e to the power minus 2x. So as you can see here, this can be written as 2e, a 2 is common, so you have a e to the power 2x minus b e to the power minus 2x. Name it as equation 2. Now differentiating 2 again with respect to x, we get, what do we get here? d2y dx2 will be equal to 2 is, if you differentiate this 2 with respect to x, it will give you 0. So we are going to differentiate only this term here. So once you differentiate here, this will give you a again twice e to the power 2x, and then minus b into minus 2e to the power minus 2x. Okay, so what we have here is 2 you can write it as 4a e to the power 2x plus minus into minus will give you plus, so plus e to the power, sorry, b e to the power minus 2x. But what is this? A e to the power 2x plus b e to the power minus 2x, it is nothing but y, so you replace it by y, so you have 4y from 1, okay, from 1, because 1 here, what is 1? Y is equal to a e to the power 2x plus b e to the power minus 2x. So to eliminate a and b, so I'm just replacing this term here by y, the value of y, because this whole thing is equal to y. So therefore the required differential equation here, so this implies that d2y dx2 is equal to 4y, or you can write here d2y dx2 minus 4y is equal to 0 is the required differential equation. So another example, say example is you are given a family of curves here. You find the differential equation. Find the differential equation of all straight lines passing through the origin. So find the equation of all straight lines. So you know what is the equation of family of curves here is the family of curves here is the set of all straight lines passing through the origin. And we know that again you have done this thing in class 12 straight line equation. The given family of curves of all straight line passing through the origin is given by y is equal to e to power mx. This is the given family of curve, and as you can see here, it involves only one constant. So by the working rule, you have to differentiate this equation once only. So you have differentiating 1 with respect to x. What we have is we have dy dx is equal to m, because the m here is a constant, so if you differentiate it will give you 0, so you keep it as constant, differentiate x only, dx gives you 1. So substitute the above value of m in 1, we get, okay. So you substitute this value of m here is equal to divide the x, replace it here in equation 1, we get y is equal to, instead of m, you replace it by dy dx into x, or you can write x into dy dx minus y is equal to 0 is the required differential equation. So I hope it is clear to you for today's class how to form a differential equation from the given family of curves. What are the working rule? The first working rule, remember, is that if you are given a family of curves involving n arbitrary constants, to eliminate those constant terms, you have to differentiate that given equations n times. Okay, so using the equation 1 and the n equations you obtain after differentiating equation 1, eliminate those constant terms. So after eliminating those n constant terms, the required equation will be the equation you obtain will be the required differential equation. So it depends on the number of constant terms. If it involves, as you have seen in the example, if it involves only 2 constant terms, you have to differentiate it 2 times to eliminate a and b. Now, in the second example, you have to eliminate, since it involves only one constant term, here, that is m. So therefore, you have to differentiate this given equation 1 once only to eliminate m. So once you differentiate it, you get dy dx is equal to m. Substitute the value of m in the given equation for a family of curve. So therefore, that equation you obtain after eliminating the constant term will be the required differential equation. Okay, I'll stop here for today. This is your first class, so we will discuss some more problems in the next class. Okay, you copy the notes. The notes also I have already sent. Okay.